Hey you guys, welcome back to the channel PHYSICSSIRJEE, and we are in Resolved series yet again, and this is Resolved-11 video, and this is a very interesting topic which actually bugs a lot of students on how to apply Gauss law when you are doing your Gaussian surface in a dielectric of a dielectric constant K. So where to put that K in that formula of Gauss law where we write integral E bar dot dA bar is equal to Q enclosed by epsilon naught. So what does that Q enclosed mean? Should we change the epsilon naught in the denominator on the RHS to K epsilon naught or not? So all those things we'll try to resolve in this particular video, and also via the problem that is given in Pathfinder. This is from the topic of current electricity, the first objective question which requires the application of Gauss law properly in a dielectric material. Okay, so without much further ado, let me first present the problem, then we'll take up the concepts one by one, and please, I request you to stay till the end of the video, because at the end I'll give you a practice problem in order to check whether you have understood the concept or not, for which I'll give the solution in the next video. Okay, so here we go. This is the problem that I'm talking about in Pathfinder current electricity chapter objective 1. Okay, so I've seen a lot of my students actually struggle with this problem with the not with the solution of it, but the basic concept of how you do get to that particular answer given in the book. Okay, so a constant current I flows in a strip line conductor, the resistivity of which increases monotonically in the direction of current flow. If resistivities at the cross sections A and B are rho A and rho B, find the excess charge accumulated in the section AB, that is throughout this volume. Permittivity of free space is epsilon naught, and relative permittivity of the material of the strip is epsilon R everywhere in the strip. Okay, so for my solution, I'll take epsilon R as a letter K, which I am more comfortable with. So that is the dielectric constant. Relative permittivity is also known as dielectric constant. So during my solution, don't get confused, I would be using K for epsilon R. Okay, right. So 4 options are given, right? You could see in most of the options, epsilon R makes an appearance, right? So K here, K square here, K minus 1 here. So let's check which of these is the correct answers. But first, the concept. So in case you want to try this question, just pause, have a go, and then come back. First, listen to the concept completely, and then again we'll look at the solution of this particular problem. So here we go, the concept first. A lot of things are there, just follow my lead. Where I'm pointing on that particular part on the screen, just try to concentrate on that. Okay, so we'll start with this basic Gauss law that we are taught. Integral E bar dot dA bar is equal to Q all inside divided by epsilon naught. What is this Q all? All the enclosed charges inside the Gaussian surface that I take for that particular flux. Okay, so Q all will include both extraneous and bound charges. Okay, so a lot of English here. Extraneous means the charge which is outside or came from outside the dielectric. It's not part of the dielectric. Okay, bound charges are those which are the induced charges due to the polarization in the dielectric. Whenever you place a dielectric in an external electric field, there will be some charge separations that take place inside the dielectric. Assuming it is non-polar dielectric, there will be some charge separations, and there would be an induced dipole moment or induced charges that would be taken. Why is that called bound? Because they don't contribute towards the current flow. They just stay at the places where they are induced. Okay, so if extraneous, that means outside charge. Extraneous means outside charge, not part of the dielectric, is Q, small q, letter small q, then bound charge is given by minus Q into 1 minus 1 by K. The proof of this entire thing is there in Irido's theory book. So if you are really interested in the rigorous proof for this particular term, you can read that Irido's theory book on electromagnetism on this particular topic. But if you are a JEE advanced student, I would recommend that you need not go through all that effort as of now. But for Olympiad students, I would recommend that. I will take up another video in which a rigorous proof for this would be given. Okay, so this is something that you need to remember as a JEE advanced student. Then what is meant by Q all? It is a sum of extraneous charge and the bound charge in terms of the dielectric constant. So you add the two, you end up getting Q by K. So this all types of charges here, if you want to write in terms of extraneous charge, then this blue letter will come at that particular place. Okay, so you should not get confused here. If you are writing in terms of extraneous charge, then you'll have to write Q by K. If you want to write in terms of all charges, all types, then it is Q all. Okay, so then if you write it here, then this will become Q by K, and I brought that K here. So this is another equation which is called as an alternative form of Gauss law. In case you have H.C. Verma's textbook of volume 2 concepts of physics, you can check, he has given the similar formula, but it's not different from this. Please do understand, these two boxes are the same. It's all dependent on whether the person wants to write this all charges or he wants to write the extraneous charge, and it is not all charge. Personally, I would prefer always the first box that I have written, this one, so that there is no confusion at all. It's complete charge that we are taking into account. Okay, right? So that's the thing that you need to understand. So this is something, if someone is writing a k here or k in the denominator, the numerator becomes the extraneous charge. Okay, so that's the first concept that is required. Then let me try to give you some basic stuff about why there is an induced charge or a bound charge that is going to develop. Okay, I have taken an example of non-polar molecules. This picture is directly taken from your NCERT textbook, so you can actually go to this particular page here and then read the entire stuff. Okay, I'll just give you basics, and whatever reasoning I give for non-polar molecules, for polar dielectrics you'll get a different reasoning but similar outcome. Okay, so because of the length of the video, I need to only take the non-polar molecules. Okay, so just watch this one on the left hand side. This gives you a depiction of how the charges are placed inside a neutral non-polar molecule when external electric field is 0. That means wherever there is a plus amount of charge, an equal amount of minus charge sits at the same place, making it almost neutral everywhere. But once you apply electric field towards, let's say, rightward direction, then the plus part moves slightly towards right, minus part moves slightly towards left everywhere, trying to create a dipole effect. Okay, right? And therefore you would say at the rightmost end there will be a positive amount of surface charge, and at the leftmost end there would be negative amount of surface charge. What happens inside volume, we'll get to that. Okay, but at least you should believe that there will be a surface positive charge and surface negative charge. These are bound charges, these are part of the dielectric, and they won't contribute towards the electric current flow. Okay, so polarizing capability of a dielectric is decided by something called as dielectric constant K. Okay, so if K is more, the polarizing capability is more. That's the simple idea you need to understand. If dielectric is uniform, that what is meant by uniform? Let me come to this picture again. Watch this one. When someone says a dielectric is uniform dielectric, that means he's talking about the amount of plus charge here and a minus charge pair, and amount of plus charge here and minus charge pair here are the same. Right, you should understand that. That means even though these are getting cancelled on their own, the plus amount here and the plus amount here could be different in general. Okay, so that is a non-uniform dielectric. Okay, so what does that mean? That means you could see here, once the separation happens, this minus goes to some place wherein there could be a plus merging with it from a different molecule. In another particular region, the plus actually comes to this place and merges and cancels that. That means in a uniform dielectric, in the volume there won't be any extra charge. But now I think you should understand, if these pluses don't match with these pluses, don't match with these pluses, then the minus here and the plus that comes to balance it won't match with each other, which in a sense makes the third point, that if a dielectric is non-uniform, then apart from the surface charge that you develop, it will also develop a volume charge density. Okay, this is something that we generally don't encounter in JEE advanced syllabus. I'll give you a simple example of what we encounter in a JEE advanced syllabus. So just move the screen. Uniform dielectric, when it is placed inside capacitor gap, remember, right? So we have capacitor plates. When you place a uniform dielectric, you are told that the charge on the plate is, let's say, Q, and this one is minus Q. I didn't write. Then on this side surface, the charge we generally write as the induced charge of minus Q into 1 minus 1 by K. You remember that? You should now think this Q is extraneous charge, this is bound charge, sum of these two at this place is all charge. And in this, we never talk about volume charge. That is because we believe that this is a uniform dielectric. So in this special case, only surface bound charge here and here will be developed, and there will not be any volume bound charge. But things will change if you take a non-uniform dielectric. So we're back to this page. So in a non-uniform dielectric, apart from surface charge, it also develops a volume charge density. Then free charge availability. this is different completely, is decided by resistivity of a material or conductivity of a material. This contributes to current. Now apart from these, there could be some free electrons inside this particular material, and how many of them are there that contribute to a flow or current is decided by not dielectric constant but resistivity or conductivity. Bound charge doesn't contribute to current. So these are basic points you need to know. What is the difference between, first of all, the extraneous charge, bound charge? Second one, what is meant by a free flowing charges, or what is the difference between resistivity and dielectric constant? Dielectric constant decides polarizing capability of this material. Resistivity decides the current conducting capability. These two are two different capabilities of a material. Okay, so let's move ahead. Now the Pathfinder challenge. I've just marked the picture from that question so that you can have a reference. This looks very dull picture, so I have drawn it again here. So what I would like to answer here is, he's talking about excess charge that is there inside this volume. Why is he interested in volume? Why not only surface here? Because he gave this is a non-uniform one, right? So the material property is changing from here to here, right? Since the material property is changing, even though it is with respect to resistivity, that would alter the property of this material. Okay, so I've just drawn this red line, and this red line I have drawn here. What is this yellow cylinder? Yellow cylinder is a Gaussian cylinder, imaginary cylinder, just like how we take. Okay, even though I've drawn it like this, just imagine these edges will match with exact area of cross section of this figure. Okay, so if the field entering this A region and field leaving this B region are depicted like this, then Gauss law for this Gaussian cylinder would be simply EB minus EA into area of cross section. That should be equal to Q all divided by epsilon naught. Once I wrote Q all, I need not write K anywhere according to whatever logic I suggested. So the value of Q all therefore is equal to epsilon naught EB minus EA into A. My job will be done if I can write EB and EA. Okay, for that I come to this place and try to apply Ohm's law, because current is flowing, right? So Ohm's law talks about J equal to sigma E, conductivity. Then I take conductivity on that side, E is equal to rho J, right, resistivity. Then at A and B, remember it's a steady current, it's a DC current, therefore current whatever is entering would be leaving. So J here and J here, current density would be same, right? J is same at A and B. If J is same, then the value of E at A would be rho A into current divided by area of cross section. So similarly, EB at this place would be rho B into current divided by area at this place. So you got EA and EB and you got the Gauss law. Combine the two nicely and you could see there is no K anywhere that we looked at. So you would end up having the required answer as rho B minus rho A. I should have written, this is rho A into I. Okay, so that should mean the option A is correct. Okay, don't go away. We are going to discuss some bonus points here about the other options, how those other options are framed. Okay, so in a future question, if they want to ask whether this is all charge. Now this all charge contains two types of charges. One is extraneous and another is bound. So let's try to calculate them also as a bonus points. Okay, now Q all I got. I'm happy that the option 1 is correct, has nothing to do with the K. As dielectric is non-uniform, you should realize that there will be a bulk volume charge density. Okay, so there will be a bulk volume charge density, and the volume of that Q bound would be simply minus K minus 1 into Q all. Okay, slightly confusing. So let's go back to the table that we wrote. If extraneous charge is Q, bound charge is minus Q into 1 minus 1 by K. Adding these two, all charge gives you Q by K. So this is something we learned from even that capacitor dielectric example. Okay, but if everyone wants to write these three numbers in terms of Q all, if Q all itself is this, then I think this number should be K times Q all. I think it's a simple manipulation. And this number would be minus K in minus 1 into Q all. Always bound charge would be of the negative sense as compared to this for obvious reasons. So you could see either represent them in terms of Q alls or you represent everything in terms of extraneous charge. But please be clear in your mind which one you are doing. Don't mix the two concepts. Okay, since you are writing everything in Q all, you can pick Q bound is equal to minus K minus 1 into Q all. Just substitute. If he had asked what is the bound charge inside this would have been the option. Okay, we can go and search whether this option is there or not. Then Q extraneous, that means the charges that came from outside this region, okay, and not part of the dielectric, or they are free charges, would be K into Q all. You could see that, right? K into Q all. That means this answer multiplied by K would have been that answer. Okay, so let's go back and see those options very carefully. This is K epsilon naught into rho B minus rho A into I. So this would have been not the answer for this question, but this would have been the extraneous charge inside that material. Okay, and what about the C option? C option would have been the bound charge. Only difference, please be careful. It would have been with a minus sign. There should have been a minus sign. So at least this has a meaning, but if there was a minus sign, this would have been bound charge. And the B option and C option with a minus sign when added give you the A option, which is all charge. He never asked in the question the types of charge. He just said excess charge. That means the total charge. And D option is just some kind of nonsense that has been developed. Okay, just to confuse students. Okay, so not only we found that the answer is A, but also found meanings for options B and C for a future question. So I hope you are ready for a future question. Okay, so and that would be our next video on the practice problem. As usual with every resolved problem, we'll take a practice problem. It's from again Pathfinder, same topic but a passage in the objective section, right? Please do take a note of this, take a snapshot or search it in the book. It's question number 22 and 23. It's a very nice question, again a JEE advanced level question that students should be very comfortable doing. And I would request you to do this question not by placing some guesswork by putting k1 equal to k2 or sigma 1 equal to sigma 2, but I would request you to get to that in a conceptual manner, because JEE would be very smart. They'll not give these kinds of options where you can substitute and check. Okay, right? So please make sure you give it a try and wait for my solution in my next video. So in case you have liked this resolved video, right, and you're new to this channel, there are many more resolved videos that we have done. So go back and check the playlist. A playlist listing is a link is in the description below, right? And also the other series, which are Pathfinder solution series, Olympiad workout series, and AITS select series, are also running parallelly, and those links are also in the description below. All the playlists, they will be worth your time. Just please go through each and every video. You will try going through it carefully. You'll definitely gain something out of those if you're watching them for the first time. Okay, so please do like, share and subscribe to my channel and keep it growing, so that I can come back with more and more quality content to help you in your further progress in the subject. Okay, thank you and see you again.